Hi guys, welcome to the second episode of the chapter 1 of our diesel engines book. Alright, in this episode we are going to finish the chapter number 1. We are going to continue with the concept of weight, with the concept of force, with the concept of torque and efficiency. Alright, what is the meaning of weight? In order to check the definition of weight, we need to verify what is the concept of mass. Mass is the amount of matter a substance contains. It is measured in kilograms or grams. Mass in science is how much matter is inside of an object. Weight. Weight is the gravitational force acting on a body. Yes, my friends. I am here in this seat because the gravity pushed me down. Without the gravity, everything floats. The gravity is a centripetal force that keeps all the elements, all the objects against the ground. How much is the value of the gravity? Is 9.81 meters per square seconds. Alright, what is the formula for weight? Weight is equal to the external force. According with the second law of Newton, force is equal mass times acceleration. In this particular case, is the acceleration of the gravity. This is the second law of Mr. Newton. What states the second law of Mr. Newton? Newton's second law details the relationship between the force, the mass, and the acceleration. If you push or pull an object in a particular direction, the object accelerates in that direction. It's simple. This is the second law of Newton. And this is the law that keep in movement all the objects on the environment. You remember in the previous book, I explained that there are three geniuses that we are going to study in details, each one. One of the geniuses that we study in the previous courses of electricity and electronics is Mr. Ohm. Mr. Ohm states that the voltage is equal intensity times resistance. Voltage is basically the force that you apply in order to increase or decrease the flow of electricity. In mechanical system, the genius is Mr. Newton, and Mr. Newton states that the force is equal the mass times the acceleration. This is the second law of Newton. And those three formulas, the formulas of Mr. Ohm, Mr. Newton, and the formula of Monsieur Pascal, they are basically the same. Monsieur Pascal in hydraulic system says that the force is equal the pressures times the area. Those three formulas have a less common denominator, and we are going to identify what is the less common denominator in those three formulas. Alright, my friends, now we are going to introduce one important concept, is the concept of work. Work in order to understand power. And after that, we are going to try to understand what is the meaning of torque and what is the difference between work and torque. Let me explain something. What is the formula for work? Work is the force applied in an object during a distance. Is force times distance. And the unit is a Newton meter. Newton per meter. Or Joule. The other name for Newton meter is Joule. This is work. This is work. Work is force times distance. and is the force that you apply. This is an object, this is the ground, and this is the force that you apply on the object in order to move the object some distance. And the work is equal to the force applied times the distance. It's simple. The work is linear. What about torque? Torque is the force that you apply to twist it a bar. For example, this is the front view of a rod of iron. If you apply a force here, and this is the radius, the torque is equal to the force times the radius. The force times the radius. What is the unit of a torque? It's exactly the same. It's Newton per meter or Joule. Those are the units for torque. In other words, work and torque are basically the same. Work is the force applied to an object, is linear, and torque is the force applied on the object in order to twist it. Torque is angular, and work is linear. That's the only difference. Torque is angular because it's force times radius, and work is linear because it's force times distance. That's the only difference. Both of them use the same units, Newton meter or joules. Yeah, the unit is Newton meter or joules. And this is the other definition of torque, is the tendency of a force to rotate an object about an axis. Yeah, it's the force times the radius. We have an example here for a torque. We are going to apply a force of 5 newtons, and the distance in between the center and the end is 40 centimeters. How much is 40 centimeters in meters? Is equal to 0.4 meters. Okay, what is the torque applied over there? The torque is basically the force, 5 newtons, times the distance, 0.4, and this is 2 Newton meters. 2 Newton meters is the torque applied on that object. This is an example in order to calculate the torque. Don't forget, work is linear, and torque is angular. Both of them have the same unit, Joule. I make a mistake here in this picture. I appreciate if you correct. Torque is force times radius, and work is force times distance. Torque is angular and work is linear. Right? Those are important concepts. I want that you keep in mind those concepts. Let me explain something before we continue with this explanation, my friends. In electricity, you remember, according with the Ohm law, we have the formula for voltage. Voltage is equal to the intensity times resistance. And what is the formula for power? Power is equal to the voltage times the intensity. And what is the unit for power in electricity? Watts. Watts. 1 kilowatt is equivalent to 1,000 watts. Alright, this is in electrical systems. Okay, Mr. Newton, in mechanical systems, state that the force is equal the mass times the acceleration. And the power is the work in a period of time. This is power. This is the formula for power in mechanical system, and this is the formula for power in electrical system. It's possible that I convert mechanical power into electrical power, or vice versa, electrical power into mechanical power. Yes, it's possible. There is a magic formula to convert mechanical power into electrical or electrical into mechanical. What is the unit of the mechanical power? The unit is horsepower. Horsepower. And what is the unit for the electrical power? Watts. And the formula says that 1 horsepower is equivalent to 746 watts. Is equivalent to 746 watts. This is an important formula. In the future, we are going to use that formula to calculate the capacity of the engine. Suppose that you have a generator, the generator is damaged, and you want to use the engine of the generator, because the back end, the electrical portion of the generator is in good condition, and you need to replace only the engine. But you don't know how much horsepower you need on the engine in order to replace the engine for a new engine. With that magic formula, you can calculate that formula. Is pretty simple. Suppose that you have a generator. This is an example. You have a generator of 20 kilowatts. 20 kilowatts. And the engine, this is the engine. The engine is broken. The back end is in perfect conditions, but the engine is broken. And you need to know how much is the horsepower, the minimum horsepower that you need in order to replace that engine for other one in order to supply 20 kilowatts. Okay, you know that 1 horsepower is equivalent to 746 watts. Okay, right now I have 20,000 watts. How much horsepower are? This is the question. Okay, is 20,000 divided by 746, and this is the amount of a horsepower that you need to replace the engine. Alright, we are going to use this formula in different ways in order to calculate power, electrical power, and convert the electrical power into mechanical power, or vice versa. Okay, this is the formula for work, this is the formula for torque, and right now this is the summary of the explanation that I did before. The unit for power is watts. 1 watt is 1 joule per second. And this is the magic formula. 1 horsepower is equivalent to 746 watts. This is the formula that we are going to use in the future to convert one power into the other one. Okay, and now we are going to introduce other important formula, the torque. Because depending on the amount of torque produced for the engine, you can produce on the propeller of the boat more thrust or less thrust. It's with the torque that we are going to do the majority of our calculation, not with the horsepower. Be careful with that, because probably you don't need more horsepower in the engine of your boat. You need more torque. That's different. It's a different concept. I receive a lot of phone calls and emails related with how much power I need in my boat in order to reach some speed, and the question have different answers. In general, when I visit the boats, I found that the engine, that that is installed on the boat have enough capacity. Normally, they don't need a bigger engine in horsepower. They only need a little more torque. How can I increase the torque? Probably with other propeller. Probably with the other propeller with one more blade. Or a little less pitch on the propeller. Yeah. Or other gear ratio on the transmission. Yeah. Or probably a little more boost power on the turbocharger. But you don't need to replace the engine for other engine with more horsepower. You need to produce more torque. Okay. And this is the $1 million question is related with the torque. The torque produces for an engine. This is an example. This is the diagram of the dynamometer. The dynamometer is too simple. This is the shaft. This is the shaft of the crankshaft. This is the crankshaft here, and you install these mechanisms. These mechanisms have a friction material here, like the friction material that you have in the pads of your brakes, and here you have an scale, and now, depending of the pressure that you apply here in this bolt, and depending of the RPMs of the crankshaft, you can produce here a vertical force, and the vertical force times the radius produce the torque. This is the dynamometer. When you visit the dynamometer with your car in order to verify how much horsepower is producing the engine of your car, they install a similar instrument on the crankshaft of the engine in order to calculate how much torque is produced for the crankshaft of that motor or that engine. This shaft could be the shaft of an electric motor or an electric pump or a gas engine or diesel engine. This is basically the diagram for the dynamometer. Once again, the people think that the most important or the critical factor is the horsepower, and no, it's not the horsepower. Is the torque. And this is the magic formula that we are going to use in the future in order to convert torque into horsepower. It's easy. The formula states that the torque should be equal to the horsepower of the engine, times the constant 52, and divided by the engine RPMs. Alright, my friend, this is an important formula. If you check that formula, the formula states that the torque is equal to the horsepower times the constant and divided by the engine RPMs. At what RPMs, idle or middle or wide open throttle, full RPMs, the engine produces maximum torque? What do you think? The engine produces more torque in idle or more torque in wide open throttle? Let me check. In general, how much is the acceleration in RPMs when in a diesel engine, inboard diesel engine, marine diesel engine? What is the maximum amount of RPMs in a typical inboard marine diesel engines? Are in between 2200 and 2500 RPMs. This is the maximum RPMs in a typical inboard diesel engine. And what is the idle? The RPMs in idle normally is around 900 RPMs, right? Don't forget, keep in mind that number. Is very important. Alright, we are going to calculate the torque in Y open throttle. Suppose that we have an engine with a motor of 200 horsepower. 200 horsepower, this is the power of the engine. Okay, we are going to calculate the torque in Y open throttle. Is 200 times 5252 and divided by the RPMs in Y open throttle. How much are the maximum RPMs? The maximum RPMs are, for example, 2200. How much is the torque in that point? Is 200 times 5252 and divided by 2200. This is 477.45 Newton meter. Alright, how much is the torque? How much is the torque in idle? The torque in idle is 200 times 52 divided by the RPMs in idle, 900. How much is the torque over there? Is 200 times 52 and divided by 900 and is 1167.11. Alright, what torque is bigger? This one is bigger, the torque in idle. Yes, my friends, less RPMs produce more torque. High RPMs produce less torque. What happens when the people accelerate the truck too much? Is too much speed, burn too much fuel, black smoke, but produce zero torque. Suppose that you want to tow your boat with the trailer. How much should be the acceleration if you try to tow the boat from the water? Low RPM. What happens if you accelerate too much? The wheels are spinning and the torque is nothing. How is the curve of the torque? We are going to do the graphic, and this is the torque and this is the time or the RPMs, and this is idle. This is 1500 RPMs and this is 2500 RPMs, and normally the curve is like this, and yes, the maximum torque is produced in idle, and normally the majority of the manufacturers, they recommend this is the operational RPMs. The majority of the boats recommend accelerate the engine in between 1400 and 1800 RPMs. This is the operational temperature. What is the meaning of that? At that range of RPMs, the engine produces the best efficient, the best fuel consumption, and the maximum torque. This is the point where the engine is working in better conditions. All right, my friends. Right now we are going to continue. This is the formula. Torque is equal 52 times the horsepower and divided by the engine RPMs. Don't forget, 52 is a constant. Okay, my friends, now we are going to talk about efficiency. And I am going to explain the efficiency in a simple way. The efficiency is, you talk about efficiency in different ways. You talk about thermal efficiency, you talk about fuel efficiency, you talk about torque efficiency. For example, the fuel efficiency. How can you calculate the fuel efficiency in your car? You have a new car and you have the catalog of the car, and the car said that the fuel consumption of the new car is 28 miles per gallon. Is 28 miles per gallon. miles per gallon. They say that this is the consumption. And you check, you fill the tank with gas, you drive the tank, and you do the calculation, and you found it that really the consumption of your car is 25 miles per gallon. This is the catalog information, and this is the real situation. It's less. How much is the efficiency in terms of fuel consumption in your car? Okay, the efficiency in my car is the real situation, 25 miles per gallon, divided by the theoretical, 28 miles per gallon, times 100. And this is the efficiency of my car in fuel consumption. You can calculate the efficiency in terms of volumetric efficiency, how much air is supposed that the engine suction, and how much is the real amount of air entering in the combustion chamber, and this is the volumetric efficiency. We are going to do that calculation. The efficiency is very important, my friends. In general, the diesel engines, naturally aspirated, with no turbo, with no supercharger, they have an efficiency around 85%. When the engine is turbocharged or supercharged, the efficiency is pretty close to 100. The gasoline engines, carbureted, they have an efficiency around 38%. What is the meaning of that? In a gasoline engines, per each $100 that you put on the tank, $38 are used to produce energy. The other $62 are on the garbage can. In a diesel engine, naturally aspirated, each $100 that you put in the fuel tank, $85 are used to produce power, and only $15 on the garbage. If the engine is turbocharged, practically all the money is used to produce power. Now you understand why the diesel engines are highly efficient? This is only one demonstration, and I am going to demonstrate during the book how the diesel engines are better in terms of efficiency in comparison with any other type of combustion engines.